This is a report on MATLAB exercise number 2, transfer function. We start off by expanding the transfer function. Using the residue command, we can define the residues, which are the numerators of the partial fraction, the poles, which are the expressions in the denominator, and the direct quotient. Notice, however, that these are simply the numbers, and you have to express them concurrently in a piece of paper, for example. So to check, however, that this is actually correct, you can run the partial fraction command, which displays the partial fractions expressed. For the next part, we then proceed to expressing this transfer function. So one way is by using the vector method. The vector method will simply take the values of your numerator and denominator, which are the coefficients of that respectively. And this will display both the polynomial form, which is where both the numerator and denominator are expressed as one polynomial, and the factored form, which means that both numerator and denominator are expressed as a series of uh, factors, which are binomials for the most part. One another way that you can do this is instead of only expressing the vector, you can also plug in the actual transfer function. You will have to use the TF for the polynomial form and the ZPK for the factored form. And as we can notice, both the polynomial form and the factored form are expressed. For the next part, you can also use this to convert our transfer function directly into either the factored form, polynomial form, and the coefficient form. However, for these three commands, this will only display the coefficients. So the factored form will only display the numerator and the denominator coefficients. And to check, you will have to use the ZPK command. So for the factored form, these are the factors, and this is the resulting transfer function. Notice, however, that the factor 2 was not expressed here. This command here cannot identify the gain, but it was specified here. The kg is the gain. For the polynomial form and the coefficient form, they produce the same set of coefficients. That's because in this specific example, and probably in most examples, they will express the same answer. That the polynomial form is equivalent to the coefficient form. And this makes sense because in the polynomial form, we are considering the coefficients of each of the orders of s. So the s4, the s3, the s2, etc. And thus, in conclusion, to represent transfer functions using MATLAB, we can use either the factored form or the polynomial form, which is equivalent to the coefficient form, using the ZPK command and the TF command, respectively. To expand partial fractions using MATLAB, we can use the residue command to display the residues, poles, and the direct quotient, but you have to express it in as yourself from the given values. To express it directly, we can use the partial fraction command, partfrac. And nothing can be said anymore about this exercise. So thus, this concludes my report.